Good day everyone. So for today we will discuss about the calculation of doses. So for today's discussion, we will tackle two objectives. First is to discuss the unit of measurement that is involved in calculating drug doses. And second is to calculate medication doses using ratio and proportion and dimensional analysis. Okay, so let's begin. So we know that units of measurements are divided into two. We have your metric system and your English system. So your metric system composed of the universal units that we are using, and we are using prefixes. So as seen in the table, so we have different prefixes and its equivalents. Okay, so like for example, for weight, we are using a unit of grams. For volume, we are using a unit of liter. For distance, we are using meter. So just add the prefix to the weight. Like for example, decigram, centigram, milligram, microgram, nanogram. So in calculating doses, the most commonly used universal unit is the grams and liter. So how are we going to interpret the table? So for example, in your DC, prefix DC, so 1 DC is equal to 10 to the exponent of negative 1, or that is equivalent to 0.1 grams. Okay, that is, again, 1 decigram is equal to 0.1 grams. So if you have 1 kiloliter, that is equivalent to 1,000 liters. So that is how you're going to interpret this table. Okay, so aside from metric system, as I've said a while ago, we also have the English system, and it is divided into two, your avoirdupois and your apothecary measurements. Okay, so this includes the pounds, ounces, grams, cripples and grains, gallon, pints, fluid ounces, fluid drams, and your minims. So the conversions are already posted in the PowerPoint. So for the practical equivalents naman, these are the conversion factors that we usually use in calculating doses. So for weight, so we have a kilogram to your pounds, diba? And pounds to gram, ounce to gram, gram to grains, and grains to milligrams. So in short, these are combination of your metric and your English system. So for the volume, we have 1 ml is equal to 16.2 minims, your fluid ounce to milliliter, pints to ml, and your gallon to ml. So the same, this is a combination of your English system and your metric system. So with your distance naman, okay, so meter to inches, inches to centimeter and millimeter, and your micrometer. So again, these practical equivalents are the most commonly used conversion factors when you are calculating doses. So after learning about the unit of measurements, let's go now to the calculation of those. So for me, I follow steps in calculating doses of medication. So the first step is to identify all the given in the problem, including all conversion factors required. So when we say given, these are the numbers that can be found in the problem, right? So when we say conversion factors, it could be either given just a problem or not. So in my case, I already include the conversion factors in the given. So I already identify them. What are the conversion factors I need in order for me to calculate for the dose? So depende na siya sa imo. Okay? Next, identify what is being asked in the problem. So after mabutang mo tanan nga given or ma-identify mo tanan nga given, you will now identify what is being asked in the problem. So, is it how many capsule, how many ml, how many milligrams, how many dose, how many days, okay? Because identifying what is being asked in the problem is very essential when you are using a dimensional analysis process. So, here are my tips in calculating doses. When there are only two units, including the conversion factors involved in the problem, use ratio and proportion. So, sa imo nga problem, including the conversion factor, kung duwa lang ka unit ang nag-involve, use ratio and proportion, because ratio and proportion is a very easy way to calculate those. Okay? However, when there are more than 2 units, like for example, 3 na siya, 4 na siya, including na nadaang conversion factor, ang mga unit that is involved in your conversion factor, a total of more than 2 that is involved in the problem. So, anong gamitin natin nga process? Dimensional analysis. So, again, these are quick and easy steps. So, let's first discuss what is ratio and proportions. Ratio is a way of comparing two quantities by using division symbol. So, like for example, milligram per kilogram. So, you will write it like this. So, mg per kilogram. Okay? So, for the proportion naman, it is an equation of two ratios. So, if you have two ratio and you are equating it, so that is a proportion. So, an example is given. Okay, now, so milligram per kilogram is equal to milligram per kilogram. So, these are proportions. So, how are we going to do the process of proportion? So, we have here a problem. How much milligram of drug should a 50 kilogram patient take if the recommended dose is 3 milligram per kilogram? Okay, so based taliwat sa steps sa ginhatag natong kagina on how we are going to calculate our dose. So, ano ganitong first step? The first step is to identify the given. Okay? So, what is your given? So, you have your 50 kilogram, no? 3 milligram per kilogram. So, you need to check. So, how many units are there involved in your problem? Okay, you have to write the kilogram and the milligram. So, in short, in this type of problem, we can use the ratio and proportion because we only have 2 units. Okay? Okay, and we are looking for a milligram, right? So, 3 milligram over kilogram is equal to x over 50 kilograms. So, always remember, in using proportion, so you see to it that the two numerator is the same. So, same also with your denominator. So, they should be, or they should have the same units. So, like for example, in our problem, so both the kilogram should be placed in the denominator. So, hindi pwede nga ang isa sa numerator, ang isa sa denominator. And then, okay, so you cross multiply, and then when you cross multiply, okay, so it will become x kilogram is equal to 3 milligram times 50 kilogram. Okay, and then so you multiply 3 milligram times 30 kilogram is equal to 150 milligram per kilogram. Your x has a unit, so you need to divide that by kilogram to eliminate the unit. So, x now is equal to 150 milligrams. So, again, our tips for ratio and proportion, this is easier to use when there are only 2 units involved in the problem. So, we will use ratio and proportion. Okay, next, let's go to the dimensional analysis. So, dimensional analysis is also known as unit factor method. It's a problem-solving method that converts one unit to another. So, it is best used in problem involving more than 2 units. So, I have here a steps for you to follow when using a dimensional analysis or when your problem has more than 2 units. So, include na ang aton nga conversion factor, ha? Okay? So, first step naton, we need to identify all the given in the problem, including all conversion factors required. So, again, for me, this is the steps. So, pag-identify pa lang daan sa given, gina-identify ko naman kung anong conversion factor na kinanglan mo, no? And then, identify what is being asked in the problem. So, the same also. So, you need to identify kung ano nga unit ang ginapangita sa problem. Third step, always place the unit being asked for in the numerator of the first unit factor. So, di ba, ang first mo ginadang ibutang sa numerator, sang imo nga first unit factor is ang unit nga ginapangita sa imo nga problem. So, like for example, kung capsule ang ginapangita, dapat ang first na nga mabutang mo sa numerator sa imo nga first unit should be capsule. Okay, say for example, i-apply ta siya. How many chloramphenicol capsule, each containing 500 mg, are needed to provide 30 mg per kilogram of body weight per day for 10 days for a person weighing 132 pounds. Okay, first naton, we will identify the given of the problem. Okay, so ang first na naton nga given, of course, each capsule containing 500 mg. So, meaning 500 mg per capsule. That is our first given. And as what I've said kanina, diba, ang dimensional analysis, dapat unit factor siya. Again, ano pag ang ibang given? So, pasunodon ta. Are needed to provide. So, we also have another given, 30 mg per kilogram. Okay? Per day. Okay? For 10 days. So, meaning for 10 days. So, ibutan na to ang 10 days. For a person weighing 132 pounds. So, may ara ta 132 pounds. So, that is now the given of the problem. So, as you can see, we have kilogram and we have pounds. So, we require a conversion for kilogram and pounds, which is 1 kilogram is equal to 2.2 pounds. Another tip, for you to sure that all the given is being provided, i-check mo kung ano ang unit na ginaas sa problem. So, for this, ginaas niya ang capsule. So, all unit, aside from the unit that is being asked in the problem, should appear in your given twice. So, what is being asked is the capsule. So, let's proceed now with the calculation. Always place the unit that is being asked for in the numerator of the first unit factor. Diba? So, again, anong ginpamangkot? That is the capsule. So, mangita ka sa imo given na may capsule. And so, that is your 500 mg per capsule. So, isulat mo siya, capsule over 500 mg. So, i-cancel na natin sa given ang ginsulat na natin for calculation. And then, ang ato next nga himuon is we will find a given nga may milligram para makancel ta ang denominator ta nga milligram. Right? So, mangita ta ara sa next. So, that is 30 mg per kilogram. So, amo na sunda itong himuon. So, you put your 30 mg per kilogram. So, i-cancel mo sa given ang imo 30 mg per kilogram and i-cancel mo man sa imo nga solution ang imo nga milligram. So, kilogram naman ang pangitaon mo nga para makancel mo siya. So, may ata sa given, 1 kilogram is equal to 2.2 pounds. So, ibutang mo na sa imo nga solution and then, you also cancel it in your given para hindi ka matalang. So, cancelan mo na siya. Next, so, cancel man ang imo nga kilogram. So, mangita ka naman pounds sa imo nga given para makancel mo ang imo nga pounds. Okay, you have your 132 pounds. So, cancel your pounds in your given. Cancel also your pounds unit. Okay. And then, after that one, may 10 days ka na bilhin. So, i-times mo na lang na siya. Times 10 days. So, what will happen now? Multiply mo tanan yung numerator and you also will multiply tanan yung denominator. 1 times 30 times 1 times 132 times 10 days. That is equivalent to 39,600. So, i-add mo yung mga capsule kaya mo na siya nabili nga unit. And then, for your denominator, 500 times 2.2, that is equivalent to 1,100. So, divide mo siya. So, your answer is 36 capsule, which is the total capsule needed for the patient for 10 days. So, that's how easy ang dimensional analysis kung i-follow mo ang ininga step. So, again, kung more than 2 gani ang units, including the conversion factor nga ga-involve sa imo nga problem, always use dimensional analysis. Again, for only 2 units naman that is involved in the problem, including the conversion factor, we will use the ratio and proportion. So, that's all about this video. If you have any questions, you can place your comment below and I can help you with regards to calculating doses using dimensional analysis and ratio and proportion. Thank you for watching.